In this video, we will solve a university question. It is from CS3501 compiler design, April-May 2024 question paper. It is a part B question. Now look at the question. Divide the following C++ program into appropriate lexemes. And which lexemes should get associated lexical values? What should those values be? Now we are given a small C++ program and the question is asking us to divide the program into lexemes and identify which of them should be given lexical values. What should those values be? In compiler design, the very first step of compiler is lexical analysis. What does this step do? It simply takes our program code, breaks into smallest meaningful units called lexemes, and then assigns them tokens and sometimes lexical values. So before solving, let's quickly revise the definitions. Lexemes are smallest sequence of characters like float, x, 100. Tokens are category name like keyword, identifier, constant. Lexical values are extra informations like pointer to symbol table for identifiers or actual numbers for constants. With this in mind, let's now go to the program and split it step by step. First step is lexeme division. The program can be divided into following lexemes: float, return or keywords, x and limited square or identifiers, minus 10.01, 10.0 and 100 or constants, less than or equal to, greater than or equal to, logical or, question mark, colon, multiplication operator, and these are operators. Open parenthesis, close parenthesis, open curly brace, close curly brace and semicolon. These are separators or punctuation. For comment lexeme, we have /*/*. Inside the comment, returns x squared but never float x more than 100. Remember, comments are also considered as lexemes, but the compiler ignores them after lexical analysis. They don't get any token or lexical value. And second step is lexical values or attributes. In lexical analysis, each lexeme is converted into a token. Some tokens are associated with lexical values called attributes. That is, some tokens carry extra information called lexical values. Keywords like float and return, they are fixed in meaning, so no lexical value is needed. Identifiers like limited square and x, they are entered into the symbol table and their lexical value is a pointer to that entry. Constants like minus 10.01, 10.0 and 100, their lexical value is actual numerical value itself. Operators like less than or equal to, greater than or equal to, logical or, question mark, colon and multiplication operator have fixed meaning, so no lexical value. Separators like parenthesis, curly brace and semicolon again have fixed meaning, so no lexical value. Finally, comments like /*/*/, they are recognized during lexical analysis but discarded by compiler, so they don't generate tokens. In step 3, we have token table for the given program. Here you apply step 2 rules to the actual program line by line. In this step, we take each lexeme from the program and write 3 things. First, lexeme itself, that is the actual text in the code. Secondly, token type, meaning whether it is a keyword, identifier, constant, operator or separator. Thirdly, lexical value, which means the extra information like pointer to symbol table or numerical value. For example, why the lexeme float has no lexical value? The word float is a keyword. Keyword always have a fixed predefined meaning in the language. The compiler already knows that the float means a data type that stores floating point numbers, since there is no extra information needed to understand float. So the lexical analyzer just creates a token like this, and that alone is enough. And identifiers like x or limited square, the compiler must know which variable it refers to. So we need a lexical value, that is pointer to the symbol table. If it is a constant like 10.0, the compiler must know the actual numerical value, so the lexical value is required. Operators like less than equal to or multiplication operator does not have lexical value, because operators have a fixed meaning in the language. Less than equal to always means less than or equal to. The asterisk always means multiplication. Since their action is predefined, so the compiler doesn't need any extra info. After that, separators or punctuation. Again, no lexical value. Separators just tell the compiler about the structure and grouping in the code. Example, open bracket opens a function call, open brace starts a block, semicolon ends a statement. So these meanings are fixed in the grammar. So again, no lexical value is needed. And comments are recognized as lexemes but discarded after lexical analysis. Thus, only identifiers and constants are associated with lexical values. Therefore, the program can be divided into following lexemes. Keywords, operators, separators have fixed meaning, so no lexical value. Identifiers and constants have variable meaning, therefore they need lexical value.